So around 2 weeks ago, I was home, sitting on the couch, getting ready to watch TV, getting ready to just check out a movie. And all of a sudden, the sky got dark. I heard a rumble outside, the sound of thunder. I saw a few flashes of lightning, and I said to myself, a storm is on its way. But before I could say that to myself, before the thought even probably came out of my mouth to say it out loud, all of a sudden the lights flickered, and then they went out, and I was sitting there in the dark. So I asked myself, well, I wonder what my other members of my Toastmaster Club thinks at this time. Do they think about where this electricity comes from? Now, I work for Tampa Electric at Big Bend Station, which is Tampa Electric's largest power generating plant. At Big Bend Station, we produce 1,700 megawatts of electricity. So 1,700 megawatts of electricity is able to power 1.7 billion 100-watt light bulbs, to give you an idea of the amount of power that we're putting out. The process of creating electricity, and there's a few processes, but today I will share with you one way we create electricity. Two, I'll share with you how the electricity makes its way to your home. And three, I'll explain to you exactly what happens, why we would get the lights flickering, and why your electricity actually goes out. Now, in order to create electricity, the first thing we have to do is change thermal energy to mechanical energy, and then on to electrical energy. We start off with the coal as our fuel source. We use coal, and we also use natural gas. Both are delivered to the plant. The coal is delivered by a railroad, or it's delivered by a barge. And when that comes in, it goes directly to our coal field, and the coal is our primary fuel source. When it's delivered to the coal field, and this is a picture here I have of the coal field, and in there it's delivered to the coal field, and we have these, you see these two bucket wheels, we call them stackers. And just to give you an idea of how high these bucket wheels are, they're about 15 stories tall. So they go out and they pretty much go and they scoop up the coal, and in the back of the stacker here, it actually has a conveyor that sends that coal into the plant, where it's pulverized, it's mixed with air, and placed right into the boiler. Now, the second photo that I have here gives a picture of, so your fuel source is coming in here and it's going into your boiler. The boiler is similar to a kettle at home. You have water in it, you heat up that water, and you make steam. The only difference is that in our actual boiler, the steam is in the actual tubes that you see here, these vertical lines here. That's the actual where you have your water making your steam. Your steam moves on to your steam turbine, where it turns your turbine. That's where you're going from thermal energy to mechanical energy. That steam turns the steam turbine, and then the steam turbine is directly coupled up to your generator, which turns your generator, and that creates your electrical energy. The electrical energy is created because the wires inside of that generator is actually in a magnetic field. It's basically the reverse of if you had a fan. So if you had a fan and you plug your fan in and you turn it on, it spins and you get a nice little breeze going. It would be the reverse if you had a way for that breeze to hit your fan. Now your blades on your fan would turn, that motor would go in reverse, and then you'd get electricity on the other end. So in the most simplest form, that's the principle behind it. Now, once the electricity leaves the generator, it's coming out at 13.8 thousand volts. Now, to give you a reference, your electricity coming out of your outlet here is 120 volts. When it leaves the generator, in order for it to travel the distances and go out on the electrical grid, it's stepped up with a transformer from 13.8 volts to 230 volts. So you're going even higher. And to give you an idea of how that transformer does it, if you had your garden hose and you're watering your plants outside, you got water coming out of the line and you have a nice small stream. But if you pinch off that line just a little bit, the flow of the water is the same amount coming out of it, but that stream goes even further. And that's the principle in the same way why we increase the voltage on the electricity. When the electricity goes out on your grid, it's susceptible to the wind. And if you look outside on your high voltage lines, many of you have seen high voltage lines outside, there's a certain sag in it to make up for the difference in the temperature difference throughout the year. So if we have a storm, the winds are blowing and those lines are actually swaying back and forth. And if those lines come into contact with each other, that creates a problem, because now that electricity, instead of going out to the homes out there, it's instead now being disrupted by the lines. And there's a device called a relay, and that relay will pick up whether or not that electricity is actually going from, it's actually going from the power plant, going to the substation and on to the customers. And if that relay finds that there's a problem and that electricity is not efficiently delivered, it takes the power out for a split second. And during that split seconds, it's like a milliseconds, and at that point it determines whether or not to go back on. It puts the power back on again, and it checks again once more. And if that fault, the lines are not touching anymore, the electricity is restored. And that's why you get the flicker in your lights. You get flicker, you get more than one flicker because you could have multiple instances of this occurring at the same time. So you'll get your light will flicker for a bit. Now if the problem is clear, your lights come back on and everything is fine. If that problem remains out there, the power is interrupted, and then you're in a power outage. At this point, Tampa Electric dispatches out linemen to go out and find out where the problem is, if there's a tree on the line, if the lines are shorted out on each other, meaning they're touching each other, or maybe a line is down somewhere out there. Now, so that explains why your lights flicker and why you're in a power outage. Now, the major point that I try to express to everyone is Tampa Electric stresses safety. We work in a very dangerous environment, and because of that, we always stress on safety, and it's the culture that we have at Tampa Electric. And I always try to tell everyone to remember that if you ever see a line out there down on the ground, don't go picking it up. We've had storms in the past where people have actually picked up those lines and they start to wrap the lines up like it's an extension cord. Not because the line is out there on the ground and it's not sparking doesn't mean that line isn't live. So if that ever happens, do not touch that line. If there's water around it, do not touch that water. And hope that helps you to clarify as to why the lights flicker, why the lights go out, and how we generate electricity at Big Bend Station. Thank you.